Hey, what's up, guys? This is Cheng here. So today's daily challenge, number 132, palindrome partitioning number 2. Right, so this one is another palindrome problem. So now we're given like a string, and we need to partition the string such that every substring of the partition is a palindrome. Okay, and we need to return the minimum cuts needed for palindrome partitioning of S. Right, so for this one, we have AAB, right? So we have 1 here, right? Because we only need to partition it, cut it once basically. For AAB, we can cut it to here, right? So that's why we have 2 parts of palindrome, and that's why the answer is 1. And then example 2 here, obviously we don't need the letter itself is a palindrome, so we don't need to do any cut. Right? So for this one, it's also 1 because we have A and B, right? Cool. So the constraints is like this, right? 2000. So yeah, so for this one, I think it's common approach is that we try to cut it every place, right? Basically, we cut it to each place, and then we see if we and then among all those cuts, possible cuts, we get the minimum cut, right? So which means that let's say we start with this kind of AAB here, right? So we try to cut it here, but obviously, if you want to cut it, right, we have to know, right, if the parts we cut is a palindrome or not, right? So for this one, let's say we have AAB, right? So obviously, we can cut it here, 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 or here. Basically, we have 4 cuts here, right? I mean, among those all 4 cuts that after this one, we know, okay, we have 1 cut, and the remaining is a B here, right? And yeah, so but if we don't use memorization, right? So I mean, the time complexity could be basically 2 to the power of n, right? Where n is the number of that, because at each of the basically the worst case scenario, like as you guys can see here, at each of the letters here, we can choose either cut or don't cut. Basically, if we have a, if everything is A, right? Basically, at each of the location, we can choose either cut it or don't cut it. So that's why the brute force way is 2 to the power of n, right? But what we can improve that, as you guys can see, so we are actually we have a lot of like we have a lot of overlap scenario, because let's say given like an S and N here, start and an end here, right? So before this one, we could have cut 1, 2, or 3, or we could only cut once to reach to the remaining string here. That's why if we don't memorize the result, right, that will be too much, which leads to a DP idea here, right? So basically with the string here, the DP, the common DP state will be just DP I and J, right? I and J means that's between the I and J, right? Between I and J, what's going to be the minimum cut, right? The minimum cut, so that the minimum cuts that after the minimum cuts, all the substrings of I and J between the string I and J are all palindrome, right? So which means the state transition function is obviously the dp of, so we have I and J, right? dp start and end basically, right? So we have basically going to be minimum, the minimum of what? Of 1 plus dp of start one start code plus the end and then end, right? So which means that the minimum is going to be, so basically we will cut, let's say we have a start and end here, right? Basically, we'll try to cut at each of the place. Of course, we need to make sure the part we're cutting out is a palindrome, right? And if that's the case, basically we'll try cut it here, here, or here, right? And we'll try all of them, and then because every cut means we do a +1, and the remaining part is going to be a dp of s hyphen, right, to the end, because we're basically we are leaving the remaining part to the another dp solution, right? And yeah, so another improvement is that every time, since we're going to calculate the if this substring, if the string we're cutting off is a palindrome or not, right? We can do a pre-calculation, right, for each of the possible string in this dp, so that we don't have to calculate inside dp. And how can we calculate that? It's pretty straightforward. I think if you guys know, find the longest palindrome, right? Find the longest palindrome given like a string. So how do we solve that problem? We use a dp, right? We do a two-dimensional dp. So where that while calculating this dp here, we're maintaining like the maximum of j minus I plus 1, right? So if we use that algorithm, basically, after this dp solutions, we have this dp I and j, where we have already find out all the possible palindromes given like a string with the I and j to be the start and end, so that we can simply utilize that algorithm, right, to help us to pre-calculate all the palindromes given given string, given the s, so that we can simply use this pre-calculated tabular of dp of palindrome to check to quickly check if this if the substring is a palindrome or not, right? And yeah, so I think we can start coding then. So first, let's try to pre-calculate that palindrome string here, palindrome dp tabular. I'm going to make it to s here because I'll be using a smaller lowercase s represents the start. So we have a is palindrome, right? It's going to be a false, right? Going to be a n for this in range n. Okay. So for I in range of that, I think most of you have already know the dp solution for finding a longest palindrome, right? Basically, we loop through all the possible indexes, right? J in range of I and n. Basically, this is palindrome I and j represents if this between I and j, if this string is like palindrome or not, right? So the way we're doing it is we check if the I is equal to the ij, right? So we check the two sides. If they are the same, then is the palindrome of I and j will depend on two things. So first, if the distance between the j and the I is smaller than 2, then it's certainly a palindrome, because so basically this one covers two scenarios. It covers one scenario, single letter scenario, and the two letter scenario. Right. So that's the two scenarios this thing covered. If it's more than 2 letters, right, then it's depending on if the palindrome of I plus 1 or j minus 1 is a palindrome, right? So basically, if these two are the same, if this is A and A, in order to check if this whole thing is a palindrome, we need to check if the inner part is a palindrome, right? So that's how this DP algorithm works. Okay, and after this nested for loop here, we have calculated all the possible palindromes. Okay, and now the only thing left is the DP, right? The real DP to cut the string. So we have a start and end, and then we have ru cache none. Okay. So the base case is like this. So if the is pal palindrome as start and end is true, then we return 0, right? So it means that if this one is already a palindrome, then we don't need to cut it. We simply return 0. Okay. Otherwise, we have answer equals to system.max size, right? So for I in range of s and n, right? We try to cut it. So before cutting it, we have to check if the parts we're cutting out is a palindrome or not, right? So if this part is a palindrome, then we can cut it, right? Answer is gonna 1 plus the dp of what? I plus 1 and to the end, right? And then return the answer. So basically, as you guys can see here, so we're trying to cut the string in all possible ways. And every time when after making a cut, we do a 1, and then we remove the cutted part out of the string. That's why we pass the remaining part into the next DP. Okay. And then in the end, we return the, we already returned the answer. So for the case, let's say if we do a B, right? So for this one, let's say if we cut it, sorry. Yeah, I think there won't be a scenario that will lead to a max size case, because anyway, the letter itself will always be a palindrome, right? So which means that so this DP will always return like a 0. It doesn't really matter how we cut it, because it doesn't really matter as long as we can cut it, because we can always cut each number. Let's say we have A, B, C, D, E, F, right? So in this one, obviously every time we can only cut one letter out, right? That's why this DP will always lead us to a non-max size answer. And that's it, right? So if I return, in the end, return DP 0 to n minus 1, right? So run it, okay, accept it, and there you go, right? So I think that's it, right? I mean, as for the time complexity, so to pre-calculate the palindrome tabular, we have n square, right? And then for this part, let's see. So I think for this one, so even though we have a for loop inside a DP here, but the total combination of the S and E will be n square, right? So that's why so this part is n square, and this is also n square. That's why the total time complexity is also of n square. Yeah, so that's it. I mean, this one is a little bit different than the regular DP time complexity analysis, where the state will be n square, right? But then within each of the state, right, we have a for loop here, right? Seems like it's gonna be a n cube time complexity. But it turns out that this DP plus this for loop, it will result to a total of n square of the DP cost. That's why the total time complexity instead of n cube, it's still n squared. And yeah, I think that's it. Okay, thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.